Yep. What page were we on? I'm sorry. 99. 99. All right. '99 through 101. Okay, what kind of questions did we come across that I could help you with? Somebody said you didn't understand something, and I forgot who said it. I apologize. Any questions I can help you with? Yay? Nay? Yes. Second one on the second page. The recruiting more nurses one. Okay, so we're on page 100, the recruiting more nurses. All right. So item one, we didn't really talk about this, but what do you think would be wrong with looking at the recruiting nurses bar graph? What do you think? You could probably say there's no labeling of the y-axis, and why would a picture graph not really be a good mathematical model for us? What do you think? Yeah. Yeah. There you go. Yeah. And then also just a picture graph. A lot of times you could do it with smiley faces or stuff like that. Though it's cutesy, mathematically it's not a good thing to do. So try and stay away from picture graphs because, yeah, it just becomes a cuteness factor, and you don't necessarily need the cuteness factor in there. What else did we see on 99 to 101 that I could help you with? Would make more sense. So I guess we should put don't use pictures for bar graph. So the easy ones say not to use would be, let me see if I can find it. So, stars. This would be really bad to use as a thing to represent a bar graph because it's just you don't want to look at. I mean, yes, it's comfortable to look at, but mathematically, it's a bad idea. And just stick with the plain Jane ordinary. Ooh, it looks gross. Don't do it. Yes, my friend. 101 part B. 101 part B says, are there any flaws in this diagram? Is that the question? Any flaws in the diagram? Okay. What aspect of this graph might be confusing? Well, it's going sideways, so I think it would look better if it's vertical. Then so human losses of World War II by country in millions and as a percent of country. So you have the amount of people lost as one of the bars, and let's pretend that was colored and it was all nicely colored. You have the number of people being lost, but then you also have a percent in there. So you have two different things you're trying to represent on one graph. You have a percent of population, and then you have the number of people lost. So mixing the two together is kind of dirty math. I'd say if you wanted to represent something like that, you should have two different bar graphs. One that shows the percent, one that shows that. Yeah?
Wouldn't that kind of be good, though, because then you're comparing it with the percentage. So when you put it in context as to, like, how many people of that country, so the Soviet Union was, like, 22 million, but then the percentage versus, like, a smaller, like, Italy, and then you put it in the percentage, and then you can compare to see who really had a greater loss.
Okay. Hi. Yes and no. I don't know. I understand what you're saying. I think that's a lot of validity to what you're saying. But I'm kind of, it'd be like, let's take this one out of let's go out of context. Let's say we want to talk about, I don't know, that may be bad. I was thinking of like boiling points of some substances in chemistry, and then percent of hydrogen in each item. I could see where you could argue you would want both, because you're trying to appeal to your eye to show, percent versus loss. Yeah, I think there's a valid argument to have it, and I think to the reader, someone could, and especially with your beautiful mind, you're able to say, I understand what this graph is saying. But I think as far as the world of statistics, I understand what you're saying, and I like that. Well, then let's retract it and say it makes it easier for us to kind of understand what they're trying to captivate. The one thing that I don't like about the graph itself, it's horizontal. I like bar graphs to be up and down. So let's say that is a major thing. Really, I do understand what you're saying, and I think that has a lot of validity to it, that you can comprehend. Like if some country said, oh, they lost 7 million, but that was 80% of their population. That's loss of life is loss of life. That's horrible. I'm not trying to discount it. But yeah, let's go with that. The bar graph probably should be vertical. That would be a nicer thing. Miss Rads, did you have the homework all done? Awesome. So kind of nice in the class. You're able to argue a point and win. I've been married long enough. I know I can't win an argument to save my life. So I'm just kidding. Nah, I don't think I've ever won an argument with my wife. She's smarter than me. What else could I help you with? Or do you feel comfortable with this concept? This concept seem okay? Perfect. All right, let's go to our next page in the notes, which when you're in the book becomes kind of the pain because we have to flip back and forth. One of these days we'll actually put the notes and the homework one section after the next. So my goal for the rest of this week, we'll do 1-3 today. 1-4 is learning how we're going to use that Desmos to do these graphs tomorrow, which puts us at Wednesday. Thursday, I believe in the homework there is a review of 1-1 to 1-3 that we'll make sure we feel good about. Friday, we will have a quiz on 1-1 to 1-3. Half sheet of paper, question came up. Does our half sheet of paper have to be handwritten? No. Okay. If you have something that you want to type up on a computer, if you have stuff that you want to condense down, it's for some sort of photocopy or print off, go for it. Your half sheet of paper is your half sheet of paper. It could be done in crayons if you wanted to. That'd be kind of fun. Markers, computers, it's your choice. Okay. All right. So I am on page 7. So we're talking about a histogram. And that histogram looks a lot like something that we've already kind of looked at. Histogram is this, and then what was the other one called? A bar graph? So a bar graph is what we had done the other day. So bar graph is not connected. Good. Histogram is. A bar graph, we usually have some sort of labels at the bottom and you're counting up. A histogram could also have something like that, but you also would have numbers. So a histogram is a way to display quantitative variables. Okay, uh-oh. What is a quantitative variable? Can't remember. Look back a couple pages. Tell me what the quantitative variable answer was. A lot of times I'll mimic it. I'll go back and I'll just kind of look. Quantitative variables may be discrete or continuous. So we're counting. Quantitative could be like temperature, people in a room, things like that. The other kind of variable was qualitative, and qualitative was you have some sort of categories. So quantitative, we have variables that can be discrete, continuous. Discrete variables are often, but not always, limited to whole numbers, observations. Technically, discrete variables have finite number of possibility outcomes, intervals, and numbers that you choose. Continuous could produce that, in theory, could be measured accurately to many decimal places. Continuous variables have infinite number of outcomes on the interval you choose. Okay, so back to histograms. So a histogram is quantitative variables, consists of bars of equal width. Okay, so the width is going to be the same. Equal width that represent the range of values along on one axis. The height of each bar corresponds to the raw count or percentage of observations that have occurred in that width. A well-constructed histogram is presented below. Okay. I think that histogram is almost good to look at. I think vertically, it's fine because it starts at 0. Horizontally, why do I not think it looks good? Horizontal, the bottom numbers. Why do I think it does not look good? It doesn't have to start with 0. I mean, you want to have 0 labeled, but go ahead. It doesn't go in order. Let's see, we go 20, 30, 40, 50, 60, 70, 80, 90.
It looks like it's kind of
Yeah. As far as the bars are just the number line itself. The number line. The bars can be that. The bars can all be different sizes. The widths appear to be about 10 apart. Where I have a problem looking at the x-axis, the horizontal part, is notice it starts at 20 as my first tick mark. And then it goes to 30 for my next tick mark, which is kind of fine. But look at how it kind of is represented. I would say that where that 20 starts and the 30 is located, I don't think from 0 to 20 on the horizontal is the same distance. I mean, we're talking about 20 units on the bottom. Here, let me draw this. So let's just make sure we feel comfortable with what I'm trying to say. So on the bottom, it goes from 0 to 20, and then that's the same distance to 30, same distance to 40, same distance to 50, etc. So these distances here are the same. But this distance here, though it appears to be lesser, I mean, this is a distance of 10, right, between each of these. But then this distance right here is a distance of 20, because from 0 to 20 is 20. But that marking on the paper is smaller. So I'm just trying to be a little nitpicky. But does that make sense what I'm saying? Okay. So it's not vital. I think they were just trying to squeeze the data into the graph size. But I agree that these are all the same. But this region here is too small to be a distance of 20. If it was a distance of 20, it should be twice as big as the regions of 10. So just be cautious when you're looking at that. And again, when I'm grading a paper, I'm not going to measure things. I'm like, oh, you're 7 7 centimeters width here, and if you're only 6.3 centimeters here. No, I'm not that guy. But I'm just trying to point out some things as far as when you're using a computer, it's available for you. You have the information to do. Utilize it. Okay, so a few things that it says. A well-constructed histogram is easy to follow, represents the data fairly. A histogram should contain each of the following features: clear tick marks and labels on both the axes. Okay, so I have something on the x-axis, which looks to be grades in a class, perhaps, and then the number of students. So the number of students that would have earned somewhere between 20 and 30% in the class would be 1. The number of students that earned between 30 and 40% in a class would be 2. I'm not sure why the region between 40 to 50 is blank. It's not shaded in. It might just be our printers didn't work real well. But there's one person that earned between 40 and 50. Between 50 and 60, there was 2 people. Between 60 and 70, we had 6 people. Between 70 and 80, we had, I'd say, 9 people. Between 80 and 90, we had, looks like maybe 13 people. And between 90 and 100, it appears we had about 5 people. Okay, so you're counting the number. So the height of the bars, when you have some sort of histogram, let's just pretend I'm doing this. This would indicate how many of somebody. Okay, so if we had a label from 0 to say 30, and then we went to 60, and then we went to 90, this bar is going to represent either the percent, and they would tell you the percent, or the number of people that fell in there. And so then in this direction, if you were to say, let's count by 5s, so then if you were to look at this, you could say this would probably represent 18 people roughly. Okay, this number right here would represent maybe 27 people, maybe 26. You'd probably get away with either way. And this other one would probably represent that there's 21 people in that category. So you're counting these categories. Okay, so the width of the bar should be identical. Okay, the vertical axis should generally begin with 0. The area of each bar must be proportional to the raw count displayed for each bar. Okay, that's just saying that I could find the area of any one of these rectangles, length times width is basically what you're doing. So in this case, you could say, oh, if this distance here is a distance of 30 and this was a height of 21, you could say the area of that would be 30 times 21, and whatever that comes out mathematically. Okay, the area is not necessarily important. It's something to kind of start considering that it does exist. The vertical axis should be generally with 0. Each area on the bar, we should just talk about that. The bars should touch. Arguably, this helps us visualize left to right flow of the data. Unlike the bar graph, the order of the bars is important. Remember, on the bar graph, your bottom was just labeling. Let's say we're labeling states. We have Colorado, we have Arizona, whatever states and whatever you're counting in those states. But the histogram itself is all together because you have a bound region. Okay, we can see that several bars peak towards the higher scores. This is important to the understanding of the way the final scores have been distributed to this group of students. The question that comes up, how many bars do we have? Okay, so let's just take an example. Let me just make up a fictitious class. Let's say I gave a class a test. It's not this class because scores are going to be much higher than this. Let's say it's an Algebra 1 class, and I'm going to give you the percents that students earned. So let's say I had these scores. These are percents. And I'm already going to have it in order for you. let's say that's the percent of an Algebra 1 class. Those are my scores, okay, as a percent. Okay, I already have them in order. But let's say we wanted to create ourselves a histogram. So I could do this. Let me bring this down. Edit, nope, file, view, dual display on. Okay. So one way I could represent this histogram is this. 0 to 100. This is a histogram of the data. Not real useful, is it? Just showing us a rectangle, single rectangle. All our data fell in there. This says that we have 17 scores. Scores were between 0 and 100. Visually, not that good. Okay. Well, what if I did this? Doing the same thing, same data. 0 to 50, 50 to 100. So I got 1, 2, 3, 4. And then, so there's 20 scores. So we go 5, 10, 15. I could say 1, 2, 3, 4. And then I had 4 of those, and there were 16. So there's 12 others that are this way. Would that histogram is also a correct histogram. So we have 2 different histograms up there. One shows 1 rectangle, one shows 2. Visually, I guess the second one we could say, oh, okay, we can see half the, how many students scored less than 50% and how many scored above 50%. We could see that. Is it visually okay? I think we can do better. So what should we maybe break with our data? What should we have I like the 5, 10, 15, 20. I think I'm fine there. And we could call that students. What should we do in the X direction? Should we count by ones?
25.
Count by 25? 25 would give us probably 4 rectangles. Would you agree with that? Is 4 enough, you think? It might be, but how many? You want to see 20 boxes? Or count by 20s? Count by 20s would give us 5 boxes, because 0 to 20, 40, 60, 80. That's 5 boxes. Is that enough? It might be. Tens? That would give us 10 boxes, tentatively. We can do it by 15s. I don't know. What do you think? What should we count by that is going to make this a good idea? I think 2 of the answers really came out, or 3 of the answers were actually pretty good. I think 5 is good. I think 10 is good. 15 might be pushing it. So let's do this 2 different ways. Let me count in green by tens. Go that way, and I have to make this a little bit longer. Okay, so from 0 to 10, there's none. From 10 to 20, there's none. Notice, but 20 to 28, there's going to be 3 people. And then 40, there's 1 person. So from 0 to 40. And then 51, 2, 3, 4. One, 2, 3, 4. This might have been really bad. 1, 2 in there. 74, 1, 2. 1, 2. Oh, boy, I wasn't that creative. 1, 2, 3. Okay, so with our cheap end data, if we tried to create 10 equal regions, that's what our bar graph looks like. But if we went a little bit further, and let's say we counted by 15s, 30, 45, right? Okay, so 30 should have been there. 30 is right there. 60, 75, and then 75 is not, and then 90. So then we do our bar graph. So nobody, or how many? 3 people fell within the up to the 30 range. Okay, 30 to 45, 1. 45 to 60. So 1, 2, 3, 4, 5. And this is a really ugly looking thing, so I apologize. 1, 2, 3. Fell within here. Or so we go up to what, 75? So there's 75, there's 1. And 76 to 90. 1, 2, 3, 4, 5. And we're making this even uglier and uglier. So the choice becomes where's enough to go? Basically, in the world of statistics, 5 to 10 might be a good amount of boxes to create. You make it work the way you want to work. It's not going to be horrible. I'd say definitely 1 box is pretty bad. 2 boxes is pretty bad. So make it from 5 to 10 increments in width. Okay. Mr. Anderson does say that statisticians will debate it. There might be some sort of equation out there that would tell you how many boxes to do. Of course, using Desmos, you can play around with it. What is desirable to your eye might be the appropriate amount of boxes, especially when you're working on Desmos, because the nice thing on Desmos is we can change the bar widths, and it will show you immediately results of what looks better for your graph. And again, we're talking about misleading graphs. Again, misleading graphs, they might have half the bars the same width. That would influence the heights, trying to gather more and more numbers into something. But the big difference between a histogram and a bar graph is the bar graph, you have some sort of categories you're labeling on bottom, so you could say like different states, and they're not separated. You're just counting out how many are there. With a histogram, you have them together, and you're talking about a range of data on the X and the Y axis that you're counting up vertically. And that's what I have. Questions? And then by tomorrow, my friends, would you please, if you have not already, load Desmos to your phone. Okay? If you don't do it by tomorrow, don't worry. There's going to be time in class tomorrow. We can still do it. All right. So, let's see. I'd say page 103, 104 would be perfect. Give you the opportunity to work on that in class. 104. If I could say a 104, I'd be better. You got, what time we at here? 11? So yeah, give me a pretty good, you should be able to do it. It's pretty quick. If you don't get it quite done by the time we hit in class tomorrow, don't panic. I'd say if you spend much more than 10 minutes outside of class on this, you've spent enough time on it. Deal?